So let's continue where we left off. Last time yesterday we left off talking about percentages, or percentiles. So let's look at an example and then we'll review. So let's say you had a data set that happened to be of the number 10 up to 100, and they're just in increments or multiples of 10. And let's say that these represent grades in a class, where these are all the grades in the class. So let's say that this is your grade, or this is your score. So what percentile would that score represent?
90. Or no, 10.
Okay, so vote for 90th percentile. What do the rest of you guys think? Remember there's a definition we talked about last time, which is the definition of a percentile? Yeah.
80th percentile? Or, yeah, 80.
Okay, I vote for the 80th. What do the rest of you guys think?
I agree with him.
Okay, good. So think about it a little bit, of what your answer should be. So, I hear two common answers, 80th or 90th percentile. So let's talk about it. So remember, the definition we talked about was the percentile of the data point was what percentage of all values that data point is strictly greater than. So this number is strictly greater than what percentage of all values. So first of all, this number is greater than how many of these numbers? It's greater than 8 of the numbers, but as a percentage of all the numbers, it would be greater than 8 out of how many values are there here, including the actual data point? 10. So this would be the percentile. It would be the 80th percentile. So again, a percentile of a data point is what percentage of all the data points is that particular data point greater than. So it's not greater than or equal to, it's strictly greater than. Any questions so far?
But doesn't it include the number itself?
Yeah, it includes the number itself, that's why we're dividing by 10. Because the number itself is included in one of the 10 numbers. But this 8 is the number of values that this number is strictly greater than and not greater than or equal to. Okay, good. And so this is going in the forward direction, where if I give you a data set and I pointed to a value in that data set, then we're asked for the percentile, which is the 80th percentile in this case. So last time we also reviewed, what if we go in the opposite direction, where if I give you a data set and I point to a percentile, like 80th percentile, then what data point should that correspond to? Well, we said that going in this direction then, that the data point doesn't have to actually currently exist in the data set. It could actually be inferred from the data set. So if we restricted it so that the data point has to currently be in the data set, then what should the answer to this be? What number should represent the 80th percentile? Or in other words, what number is greater than 80% of all the values that currently lies in the data set? Yeah, the number 90 that is currently in the data set is greater than 80% of all the values. That's if we restrict this answer of the 80th percentile to be currently in the data set. But we said that if we go in this direction, the answer doesn't have to actually currently be in the data set, it can be inferred from the data set. So we can actually pick any number here, as long as it's greater than 80% of all the values. So if we infer the value, what are all the possible values that is greater than 80% of all the current values that could be inferred from the data set?
90 and 100.
Well, again, those are if we restrict the answer to currently have to be
Oh.
values in the data set. But what if they're values that don't have to be in the data set? They can be inferred from the data set.
So anything greater than 80.
Yeah, basically anything greater than and not including 80 up through 90 would be values that would be greater than 80% of all the values. So here, if we don't limit ourselves to values that are currently in the data set, if they can be inferred from the data set, then anything between 80 and 90, not including 80, I'll use this notation. So round bracket means we're not including 80, and square bracket means we are including 90. So you notice that in this case, there's an infinite number of possible values between 80 and 90. So we have more flexibility in this direction. So going in this direction, if you're asking for the percentile and if you're given the percentile and asked for the data point, then there are an infinite number of possible values. So there's a certain formula we use so that we're all roughly on the same page and we're not giving an infinite number of possible values. So the formula we talked about last time was in this direction, that the rank of the answer is equal to n plus 1 times the percentile as a decimal. So let's try to apply that in this example. So in this example, how many values do we have?
10.
Yeah, 10 values, so n is 10. What's the percentile as a decimal? So if we want the 80th percentile,
0.8.
yeah, it would be 0.8. So if you take 11 times 0.8, you're gonna get 8.8. But that corresponds to the rank of the answer. What the rank means is that if you were to sort all the numbers in order, and you number the positions or the ranks, then the rank of the answer that we want would end up being the 8.8th number. And the 8.8th number is the number between the 8th number and the 9th number. So just like we expect, the answer should be between 80 and 90, which is between the 8th and the 9th number. But when we have a decimal rank like this, last time we talked about how we're going to take the average of those two endpoints. So we're going to take the average of the 8th and the 9th number, and so we're going to add 80 and 90 and divide by 2. So in that case, that'll be 85. And when you take the average of two numbers, really that's the same thing as taking the midpoint of the two numbers. So the midpoint is the number that is the same distance away from the bottom number as it is from the top number. So this will be 85. So we're going to use this formula to find the rank of the number that corresponds to a certain given percentile. And in this case, that answer ends up being 85 because it can be inferred from this rank of 8.8 or the 8.8th number, which is the average of the 8th and the 9th number. So anytime we have a decimal rank, we're going to take the average of those two endpoints. If we had used this formula and we got a rank that was not a decimal, that was exactly a whole number, like exactly 8, then we would just use the 8th number and not take any averages. But because we're getting a decimal rank, we're going to take the average of the endpoints. So if you use this formula and you get 8.2 or you get 8.9, we're still going to take the straight average. But if you get exactly 8, then you just get the 8th number and then not take any averages. Any questions? Okay, so the point is if you're given a percentile and you're asked for the number representing that percentile, then by definition, there can be an infinite number of values. In order to constrain that, so we're all on the same page and we're getting the same answer, we use this formula to get the same consistent answer. And if you use this formula and you get a decimal rank, we're going to take the average of the numbers at those endpoint ranks. So here we're taking the average of the 8th and the 9th number. And so the final answer here is going to be 85. And so that represents the number in the 80th percentile. And so That's consistent with definition because this number 85 is greater than 80% of all the values in the data set. And we said that by definition, there are all these other numbers that conform to definition, but we're all gonna be consistent and use this as the final answer. Any questions? Okay, so one thing I wanna emphasize is if you look in your book, you'll notice that for the same concept, they use a formula that looks different. So the formula the book uses is this formula. The rank is equal to just n times p rather than n plus 1, the quantity times p. So let's say that you use this formula in the book. If you wanted to find the number at the 80th percentile, according to the book's formula, that's going to be n, which is 10 numbers here, times p, which is what in this case? Yeah, which is 0.8. So the book's formula is going to tell you that the rank is going to be 8, or the 8th number. So what is the 8th number in this case? Yeah, the 8th number is 80. So does that fit the definition of a percentile? Does this number, 80, is it greater than 80% of all the values? No, it's greater than 70% of all the values. So the number 80 here is actually the 70th percentile, not the 80th percentile. So if you use this formula in the book as is, you would not get the right answer. But the reason the book suggests this formula is that you have to go through another step. The book says that if you get a whole number here for the rank, then you're gonna have to look at the next number and then take the average of the two. So it just requires another step that is not intuitive. So what I would recommend is using this formula we talked about in class. So you can use the book's formula as long as you go through another step. You can't just stop at this formula. But if you use the formula we talked about in class, then you can basically use the formula as is. Any questions?